If you drive around many of our South African towns and cities, seeing solar PV generators on house and business rooftops is becoming common. Why is this? What are the implications for electricity distributors, and what does this mean for the future? In this video, we will discuss 1. Global and local trends around renewable energy. 2. The characteristics of the technology being installed by customers on municipal networks. 3. How a municipal distributor can respond to the challenges posed by these new trends. And finally, how municipal revenue impact can be addressed. We will also point to further support and resources available for municipal distributors. We also hope the video helps clarify some of the misunderstandings that customers have, who sometimes can be critical of municipalities around the conditions that are put in place for SSEG. Renewable energy technology is improving, and costs are dropping to the extent that it now provides some of the cheapest energy in the world. All over the world, installations are accelerating, and South Africa is part of this global renewable energy revolution.
At this point, as we stand right now, solar PV is the cheapest form of energy generation as we speak in the world of all different available sources of energy generation, and it's still getting cheaper as the economies of scale are kicking in.
It's inevitable. You cannot really avoid it. It's going to happen either way. So cities have to be innovative. They have to find ways of working with that, because that is the future, really.
So you could see that the solar applications from the city of Johannesburg's perspective are increasing. Actually, it is doubling every year.
The need to respond to climate change has driven the global investment in such clean, low-carbon energy. But renewables are also an important contributor to job creation. At a national level, significant amounts of large-scale renewable wind and solar energy has been included in our official National Electricity Plan, the Integrated Resource Plan, or IRP.
The renewables, we think, is the future for electricity generations.
Small-scale embedded generation, or SSEG, is also taking off. Small scale refers to systems up to 1 megawatt in generation capacity. These systems are installed on the electricity customer's property behind the meter and connected to the grid, thus embedded in the network. This trend is driven mainly by rising electricity prices and load shedding. Most SSEG systems being installed in South Africa are solar photovoltaic electricity, or PV SSEG, which is the focus of this video. But keep in mind that the principles discussed here generally apply for all generation, such as wind, hydro, diesel, and others. We now have tens of thousands of PV SSEG systems installed in South Africa, totaling over 400 megawatts. That's a lot of energy, enough to power at least 100,000 households. But is this acceleration of SSEG installations a problem for distributors? No, it need not be. Firstly, let's remember that municipal concerns about growing SSEG numbers are understandable. Since the first power station and distribution network was constructed in South Africa around 1890, power has been flowing one way, from power station to the customer. Technical staff were trained to understand, construct, and operate systems with this one-way flow. SSEG turns all this on its head by installing generators at the customer end of the network.
Only transmission engineers or engineers planning the network at transmission level used to worry about generator integration challenges onto the system. So now that is past, even municipal planning engineers now need to start about where generation challenges onto the system.
This video will show why SSEG does not pose a threat to municipal distributors or to human safety, as long as the right requirements and the right tariffs are put in place. However, it is also worth noting that SSEG can definitely be a problem when, firstly, the distributor has no requirements or tariffs in place yet for these installations, or secondly, when SSEG customers or installers disregard municipal distributor requirements. Such illegal installations are the worst outcome from a safety, power quality, and municipal revenue impact point of view. The best approach is to develop processes which allow and encourage customers looking to install SSEG to do so legally and safely.
So unfortunately, where the processes are not in place, the guys that wouldn't follow the rules and processes anyway end up installing systems, whereas guys that do want to do things right according to standards and regulations end up not installing and actually getting stuck. So the municipality ends up getting bad installations that actually happen, whether it's illegal or not, and the good installations actually don't happen.
It is important for municipalities to have processes to allow SSEG. There's a lot of reasons for that. One of them is for them to be able to monitor how much SSEG is connected into their system, to monitor in terms of the dangers around safety that could come up with having SSEG installations that you don't even know where they are in your networks.
Many municipal distributors have already developed these processes and requirements to accommodate SSEG. They are also developing tariffs to ensure that SSEG customers are still covering their fair share of network costs, so municipal revenue is protected, while at the same time keeping a reasonable business case for the customer. Let's look at the main components of a typical SSEG installation. This is a photovoltaic or PV panel. Each square meter of panels produces about 170 watts of electricity, typically at midday on a sunny day. That's about the power used by a big refrigerator. This is an inverter, which converts the power produced by the PV panels to be compatible with the network power. Here is a battery. Several different types are available on the market, and they can look quite different from each other.
As an example of a solar PV system, here is our office block with 14 kilowatts of solar on the roof. It cost us approximately 150,000 Rand, and the payback period is 4 years. Let's look inside the building to see what's happening right now. We've got some electricity meters which show the real-time generation and consumption. Right now, the solar panels are generating 8.3 kilowatts of electricity. At the same time, the building is only consuming 6.1 kilowatts of electricity. So we're actually exporting 2 kilowatts into the City of Cape Town's grid, and we'll get compensated for that at the end of the month.
Now, let's look at how these are put together. Here is a very common system configuration. The PV panels generate power when the sun shines, which feeds into the inverter. The inverter changes the power characteristics to feed into the customer wiring and network. The meter is called a bidirectional meter because it can record energy flow from the grid to the customer, as well as export from the customer to the grid. A second configuration includes storage. This is becoming increasingly common as it allows the customer to function when there is load shedding and can provide power when there isn't sunshine. The power from the PV panels feeds the appliances of the customer, as well as charging the batteries for backup power. If there is still extra power from the PV panels, it can be exported to the grid through the bidirectional meter. A third configuration worth knowing about is an off-grid configuration. Here, there is no physical connection between the PV system and the wiring of the customer, which is connected to the network. It is therefore not an embedded generator, so cannot be called an SSEG. Now, let's have a closer look at how typical PV SSEG systems operate. First, we use a house as an example. Often, not much power is used in the middle of the day. For example, if people are away at work. More is used in the evening again. The PV generation is at its maximum in the middle of the day. You can see that for a lot of the day, there is extra PV power. This can then be exported onto the municipal distribution grid or used to charge batteries if they are installed. Another example is a commercial building, like an office or a mall. They typically use a lot of energy during the day. The solar PV system generates during the day, but the energy is all used on the premises. So usually, commercial systems export little or no energy back onto the grid. But note that whether or not an SSEG system exports power, the fact that it is embedded means that it can affect the network and so needs to comply with various technical requirements. What about the money side? Let's look at the customer's perspective and the municipality's perspective. First, the customer. PV SSEG requires a significant capital outlay, so the business case for the SSEG customer or investor is an important consideration. A 3 kilowatt system, typically installed on a residential property, would cost around 75,000 rands and take at least 15 years to pay itself back. A 50 kilowatt system, typically installed on a shop or a small office block, would cost around 750,000 rands and take 4 to 6 years to pay itself back. A large 1 megawatt SSEG system, typically installed on a large mall, would cost around 10 million rand and take around 3.5 years to pay itself back. Residential payback is slower than commercial payback. Why is this? Because households tend to export quite a lot of PV SSEG energy during the day rather than use it themselves. As a customer, it is better financially to use your PV energy generated than to export it to the network. Now for the municipal financial perspective. A common concern is that the municipality will lose money if customers install SSEG because they will be buying less units or kilowatt hours from the municipal distributor. Loss of revenue is understandably difficult to accept, but this will only occur if these SSEG customers are on an unsuitable tariff. If you have a suitable tariff, there is no threat to municipal revenue. Simple as that. This has been demonstrated in analysis done in over 30 municipalities from around the country.
SSEG is a new business model for them, so it's not here as the bad guy to the business. So the more they respond positively to it and be more prepared to work with SSEG, the better for the municipalities' revenue collection and the alternative revenue streams as well.
How does this work? The basic principle is to ensure that SSEG customers go onto a tariff which has a fixed charge, which adequately recovers the fixed costs of the distributor. Then it doesn't matter how many units they do or don't consume. The municipality still recovers the revenue they need. Keep in mind that the municipality can also use the energy exported from the SSEG customer as a source of revenue. For example, if they credit an SSEG customer with 80 cents per kilowatt hour for exports, they might on-sell this power at 2 rands per kilowatt hour.
I think a couple of years ago, there was that notion that SSEG is taking up, the revenues for municipalities. But I think as time went, municipalities started to understand that this could be a new revenue stream, alternative revenue for municipalities, and this could be a win-win for customers and municipalities as well, in terms of customers being able to even sell back the excess that they have from their SSEGs, and for municipalities to be able to supply other customers using the excess generation as well.
In summary, remember that tariff setting can protect municipal revenue while also being fair to the customer. We've demonstrated this in working with many municipalities around the country. Badly designed systems can indeed be unsafe and affect the network power quality. Municipalities are correct to be concerned and must ensure the proper requirements are put in place and are complied with. Fortunately, standards, specifications, and processes have already been developed to ensure technical soundness of such installations. So the municipal distributor just needs to adopt these and make sure that SSEG customers comply before they are given permission to install. SALGA and the AMEU have endorsed a set of documentation and processes for use by municipal distributors to allow SSEG onto their networks. This SALGA AMEU resource pack, as it has come to be called, draws on years of experience by pioneering municipalities and other experts in the country, and is in line with international best practice. Using this resource pack, municipal distributors can quickly and easily be in a position to allow suitable SSEG systems to be connected to their networks. More than 40 municipalities around the country are already doing this.
SALGA's role in assisting municipalities with SSEG challenges is to make sure that municipalities are well prepared, well capacitated, first to have processes in place to allow the SSEGs, and also to make sure that the technical staff is well prepared and well trained to be able to respond to this new phenomena of SSEG.
Maybe one thing that assisted in the development of SSEG processes would be our interactions with other interested stakeholders, Sustainable Energy Africa, SALGA, AMU. In that way, we were able to look at what other municipalities are doing as well. And then from there, we developed our application forms. And then we also developed the entire standard operating procedures for the city. And then that's where we are right now. We are also watching the space in terms of what other cities are doing in terms of tariffs. What City of Cape Town has done and what others are busy doing. That will assist us in better implementing what we intend to do going forward.
So we hope this video has provided clarity around the following issues. 1. What SSEG is and how it works. 2. That it is a growing trend which all distributors need to respond to. 3. That SSEG can be accommodated onto municipal networks safely and without any adverse effects. 4. That negative revenue impacts can easily be avoided for municipal distributors by setting appropriate tariffs while still being fair to SSEG customers and investors. And 5. How a municipal distributor can relatively quickly set up a process to allow SSEG installations in a safe and legal manner. If you would like further support, you can look on the Municipal SSEG Support Resource website. www.sseg.org.za. Most of the resources mentioned in this video are available there. There are free online training resources at www.training.sseg.org.za. You will need to create an account, which is free. We also offer periodic online or face-to-face training courses on SSEG. Email support@sseg.org.za to be kept informed.